So hello everybody. Good morning. Can you hear me?
Yes, sir.
Okay, cool. So let's start our lecture. So I'll start my sharing. We will start in another 2-3 minutes. Let the others also join. Okay. All right. So once again, good morning, everyone. Let's get back to our lecture. Before I begin the lecture, is there anybody who have, good morning, everyone. You know, is there any doubt? Is there any question that anyone have with regards to the last lecture that we covered? And we went into the territory of the Kubernetes that I would be continuing right now. And then in the later half of this lecture today, we are going to see some of more demos. In the last lecture also, we saw the demos about the Docker on the local. However, we didn't saw the demo of the Docker at the cloud. That is our one of the main agendas. We wanted to learn about how the Docker can be leveraged into the cloud. So we're going to be looking at that today as the time permits. So let me begin now. So guys, in the last lecture, we saw an introduction about the Kubernetes. Today, I'm going to begin into some of the more deep dive concepts about Kubernetes. And before I begin the lecture, I want to remind you that feel free to please let me know in the between if you find the speed of the lecture little high or little less. So if you're not able to understand any particular aspect, then do let me know, and please raise your hand or unmute yourself, and then we can have a conversation and I can help you to understand on this. Okay. Now, with this, what is a pod? Now we already have an understanding, my dear students, about the pod. So pod is used basically to host a container. That's what like the most important understanding about the pod. But technically speaking, we can have we suggest to have one container per pod. But in reality, a pod is capable of hosting more than one container as well, theoretically. Okay. So that's where like the pod is. Let's move further into the pod. Here we are looking into an example onto your screens where there is a web app being hosted. Now this particular my app container is hosted inside a pod. As you can see, the pod have got an IP address from the virtual network. Okay. How to create the pod? We shall get to see these details in a while. Pod is the smallest unit of the Kubernetes. And what is this pod? Why is that it is the smallest unit of Kubernetes? Why is that we cannot have a container directly running? As you can see, pod is nothing but it is a layer of abstraction created over the container. If I only have a container, then the Kubernetes would have to work with the containers. But I have various types of containers, for example, like Docker, Rocket, etc. So how will I make sure that the Kubernetes would work with each type of container? Because each container would have a different type of working style. So in order to abstract all of these things, there came a concept of pod. You create a container and that container would go into the pod. Okay. So therefore, pod is the smallest unit of the Kubernetes, which would host either a single container or a couple of containers. Okay. And this container could be of any type. That is, it can be Docker, it can be Rocket, it can be LXC, etc. But for Kubernetes, what it is looking at is that is nothing but it is a pod. And each of these pods would get an IP address. As you can see over here in the diagram on the right hand side on your screens, the node already have an IP address, and then this pod which is running also gets an IP address. Okay. As I already told you, my dear students, there is usually one application per pod. Now, when I say application, It is not the full-fledged application. It's one task per pod, and each pod would get its own IP address. Another important thing to note here is that these pods are also amphibarals in the nature. What is the sense of it? It means they have to die and restart. So who would do the restart? It's the Kubernetes who shall do the restart. But when it is going to the restart, it may not get the same old IP address. The IP address would be different, and that shall be new all the times. So whenever it restarts, whenever a pod restarts, I mean to say, the new IP address is going to come to it, and this can be a problem, isn't it? With this particular pod getting a new IP address each time, how I'm going to access it all the times, right? I don't want to change my IP address again and again. So to deal with this problem, they created one more abstraction layer over the particular pod, and it is called a service. I have the pod, which is running the application inside the container. And this particular pod would have an associated service, which would have the permanent IP address. And the best part is that the lifecycle of the pod and the lifecycle of the service is not at all connected to each other. They are separate. What it is meaning, if a pod dies with a container, let it die. Now, when it comes back, and even if it gets a new IP address, as such, with respect to the endpoints, they would be mapped to the same service, and it would still be able to communicate. How does this internally happens? When we look at the config file, we shall be able to understand it more better. So now I have my application. My application is running inside a container. On the top of the container, we have an abstraction layer, which is called as pod. The pod has another abstraction layer, which is called as service. Service have also got an IP address, and pod have also got an IP address, and a node has also got an IP address. And the life cycle of these pods and services are not connected to each other, meaning to say, if a pod dies, let it die and then come back again. The service is going to be remapped, and it is going to continue to work the way as it is. So now I have my application, and I also have my service. Now this particular service would have an IP address. Now this application, whatever I have installed and deployed, it should be accessible through the browser to the outside world. So how do I get access to it? Obviously, I need to use the node IP address with the port number. Okay, how do I assign the port number? These things would become clear when we go and see the configuration files. Till then, I request you to kindly hold on. For the containers, there is something called as node port. There is something called as a container port. Okay, I would have to explain certain details with an examples. Till then, I request you to please hold on. Okay, so this particular service, so I have my application, which is a service, which is a front facing, that is meaning to say, users shall be using this application. I also have a database. Database also has a service because it also requires a public net IP. Okay, and here I should make sure that the database should not be accessible by the outside world. Okay, only my application should be able to be accessed by the outside users, but not the database, because we do not want to expose my database outside to the world. I only want my database to be accessible by my application. Whatever database is it, maybe you are using Mongo, maybe you are using Cassandra, maybe you are using big database, big table, etc. Or maybe you're using, like in the Google parlance, Bigtable, or maybe in the Azure parlance, you're using Cosmos, or in the Azure, you're using like the Dynamo. And that's the reason we would try to access our DB using the IP address of the DB along with the port number. Then you will not be able to access it. So in the configuration, we will specify that my application shall be configured as an external service, and my database would be configured as an internal service. And another thing to note here is that the internal service by default is internal. Okay, if you want to make a given service as external, then you would have to specify the same as external. Okay, and how is it done? Again, as I said, this has to be done in the configuration file, and I would show you the configuration file in some time. Okay, so this is about the service. The service is capable of doing the load balancing as well. That is a very important thing that you should really note it down. Another problem. What is another problem? Whenever I want to access the external service, okay, first of all, what is external service? My application, which is installed or deployed in the container, and the container is running inside the pod. The pod is running on the top of the node, and I want to access, and then over the top of the pod, I have service. Now I want to do, what do I do? I give the IP address followed by a port number through which I access my application. And since this is an external service, therefore this is being exposed outside to the world. But is this good for the end users to access the application like this? Obviously not. The problem here is that I need to give a domain name and a port number should also be internally mapped to it. Okay. With the domain name, I should be able to access my application. That's how it should work if I'm talking about the application, external application. That's where the ingress comes into the picture, my dear students. Ingress is a mechanism with the help of which you can configure a secure protocol and domain name with a port number in order to specify that, hey, whatever the requests are coming in, they would not target the service hosted inside the node, but it is going to target the ingress. So ingress is going to forward the request to the specific service. Okay. In that way, what I can have is I can have a domain name like myapplication.com, and using that I shall be able to access my application. So I have seen a pod, which is an abstraction over the top of the container. We have seen a service, which is an abstraction over the pod, because pod dies and restart, where the services are permanent. And then we looked into the external and internal service, and now we have looked into the ingress as well. Okay. So here what we are looking at is I have created a service. What is the service? This DB on your screens on the right hand side is the service, and I have named it as MongoDB. Please note, it is going to be an internal service because I want my database not to be exposed outside to the external world. So MongoDB has a service endpoint. Okay. Now my application also has access to the MongoDB in order to access and store the data and the values. So this MongoDB as a service endpoint is noted in my application. Okay. But what if at the same point of the time I configure the MongoDB as a MongoDB service? I changed it from MongoDB to MongoDB service, right? Change the name. What would happen? Now my application obviously do not get the access to the DB. So now what it should do, this particular service endpoint where it is noted, it is always noted in the application, right? We try and embed that particular endpoint in the application. Since it has changed now, I should go and access the source code of that particular application, and I should rebuild that particular application with that new service endpoint. And then I need to push it through the repo and again pull it into the pod and create that new pod as a fresh one and do the deployment again. With this, the new MongoDB service endpoint shall be accessible. Okay, but isn't it so much of the pain? I changed a particular service endpoint and that had to go through a lot of headache. This was because the endpoint was embedded into this particular service. I mean to say the endpoint of our database was embedded into my application. That's why it became so much of the headache for us to do a rebuild for the entire my application. It was there in my application and I had to change the tab, and thus everything really got into the puzzle effect, right? So isn't it better if I keep this service away? If I keep this away, yeah? Yes, it is possible. And for that, we use a component of the Kubernetes called as config map. A config map holds the known confidential data only, like what? The database URL. Okay, so what do? We create a config map, and the config map will have a database URL. We create this particular config map, and using the key value pair, which is present in the config map, I would be accessing it. Again, how is it done? I'll show you through the examples short while. So in this way, I have externally configured the URL now, and therefore I do not need to rebuild my application or recreate my new code if it is required. Because what is that? What is that which is changed? The change is only happened in the config map. Okay. The URL remains the same. The endpoint still is the same, but only the URL inside the config map is changed. Okay. All right. Now there is another problem. Not a problem, I would say, but another thing that we have to take care of. That is the MongoDB user as well as the password, which is also there. If I try and keep this MongoDB, if I try to keep this MongoDB username and password in the config map, it shall be visible to everyone because this config map is not maintained with confidentiality. Okay. For this, we have another configuration file, which is also called as secret. The secret helps us to store the secret data, which is nothing but the MongoDB username and the password. Usually, they shall be present in the encrypted form. In order to do the encryption, of course, Kubernetes would itself not provide you any option. To what extent it can provide you? The option is to present this username and password in the base64 encoded format so that it is not present in the plain text. Kubernetes would not encrypt it by itself. But why at all we need to encrypt the data? It is because the base64 does not provide the security. And that's why we need the encryption to secure the data in a production environment. Just encoding the data in the base64 is not the best solution. If you want to encrypt the data, then you would have to use some third-party tool or tools provided by the cloud providers. That's how the purpose of the secrets is. So in secret, we try and maintain the various passwords, various certificates, which needs to be maintained with confidentiality. Okay. Now coming to the next one, which is volume. Now if I try and save the data within this DB container itself, note that the DB container is present in the DB port. These containers are ephemeral in nature. That is, they can go down and would be restarted. When these go down and come up, we know for a fact that they do not persist the data. Okay, so whenever the database container restarted, the data shall be gone, for which the volume as an option is provided, where I can create a local storage on the node itself, or I can create a remote storage outside the K8s cluster. But the Kubernetes does not manage the particular data persistent as such. That is the user who has to do this. Okay, but it definitely gives you an option to map this volume, which is present on the local storage or the remote storage, into the database container itself. Okay. Next, we shall move on to how to access these applications using the browser. So we have an application. I repeat from the beginning, please pay attention, everybody. If you have been missing so far, I request you to please be attentive now. What I'm saying is, I have an application. This application is running inside the pod. This application is running inside a pod, which is exposed through the service, exposed through the ingress as well as such as well. The service is exposed through the ingress. Now I have my config map where I store the, the confidential information like the access credentials to the database. Now, what if my application goes down? Of course, there is a self-healing feature such that if application goes down, then the container would come back again. Meantime, there might be downtime as such that I would not be able to access my application using the external service. So what do? Obviously, I need to make use of replication where and this replication basically would come through the configuration itself. And this is done in the service part. So you specify what container you want to use and how do you want to run it. Also, those things that you specify in the specifications, that what is the replication order? Is it 2? Is it 3? Something like this. You would have to provide. When I say a port over here on the right hand screen, this is not going to get a separate service. For both of these applications, it will use the same service over here. So do not get confused. There is a separate service over here. No. Another service means that there is a new IP address. So there is a single same service which shall be mapped to both of these replicas. So I have I have my application and I have my application replica, and both of these replicas would make use of the same service. Through the same IP address, who shall be able to access either the my application or the my application replica? If one particular container goes down, obviously the service knows that there is another replica running. So it is going to forward the request to this. Okay. By default, if you have two My Application containers running, then the service shall also act as a load balancer. So the service is going to forward the request to the least busy server or the one which is available right now. And hence internally, the service would look into the load balancing as well. Okay.
Sir, I have one doubt.
Yes.
So can you help me explain why did we use config map? So you mentioned confidential credentials for databases, but the secret service is for that, right?
Mm-hmm.
So why was config map in place? Why did we use it?
Very good question. Thanks for asking. So see, config map in the Kubernetes. Tell me one thing. Imagine that you have to store the credentials. For example, like the configuration data I'm talking about. So it is not the application code. It is different from the application data. So if you have like the uh, you know for example, like environment variables, you have config files, you have some arguments and the key value pairs. Where would you store that? That is where our config map comes into the picture.
Okay, so secret is entirely for credentials, while config map is for other configurations as well, right?
The config map is for the configuration data, but yet people use it to store the secrets as well. But secrets, what I mentioned is that the encryption of the secrets is the responsibility of the users like us. Kubernetes does not provide any inbuilt mechanism for the encryption of the data by its own. So if you have to just understand the config map is just a place to store the configuration data which is provided out of the box by the Kubernetes.
All right, sir. Thank you.
Okay. Secret usually is used to store the sensitive data like the passwords in the base 64 encoded format. But usually in the production environment, you would like to go ahead with storing the encrypted data also. Secret I mentioned about this, yeah. Is secret clear to you?
Yes, sir. Secret is clear.
Perfect. To everybody who are not clear, the secret is also similar to the config map, but specifically it is designed to store the sensitive data securely. Like for example, the passwords, API keys, certificates, etc., like the database connection strings, etc. Okay. Mhm. Okay. Volume is
Sir, I have
clear.
a question. Sir,
Mhm.
I have a question. Here we are saying that DB is running inside a pod, but typically pod will go down and come up. Shouldn't probably DB shouldn't be part of pod that way, isn't it?
Yes, yes. That's what I mentioned, right? I'm just
Okay.
taking an example here, uh, just for the illustration that if
Okay.
you have the database running inside a pod, then how can you really have a volume associated with that particular pod so that even if it goes down, then the data is not lost. But in the real world production systems, of course, the database should not typically run inside a pod except for the testing or the deployment development purpose.
Okay, I see. Yeah.
Okay.
Thanks.
The
Sir,
data, one sec. Let me complete my thought. The database should be running as a complete managed services. Usually in the production environment, you would like to go with either, like for example, Amazon RDS or Amazon Dynamo, or maybe you would, if you are into the Microsoft ecosystem, you would go with Cosmos or Azure SQL database, right?
Yeah.
And it would be running outside the Kubernetes. And
Perfect.
why we should not store the database inside it? Why we should not host a database inside a pod? Is because the nature of the pods is ephemeral in the nature.
Right.
Say ephemeral, they can be killed, they can be restarted, they can be rescheduled at any given point in time without your further notice.
True.
If code dies, all the DB data stored locally inside the container would be lost until and unless you have the persistent volumes configured. And that's where I tried to show you the example of the persistent volumes. Number
Yeah.
two, sometimes you also might require the database to scale up vertically, which is which is which is most of the cases. And whereas in the case of the pods, they can only scale horizontally. They can scale vertically also, but usually in the case of the Kubernetes, you would prefer to add more replicas so that it scales horizontally, right? So,
Yep.
so that's way. And number three, the most important thing is in the production systems, you would like to have the scheduled backups, failover setups, and replication, right?
Yes.
Which is provided much better in-house by the cloud services already. So why would you need to build your own framework for that? Okay.
Yeah.
So there, the Kubernetes, I repeat to everybody, Kubernetes is better for the stateless applications. It is not meant to run the heavy stateful workloads. Like for example, what I mean by the stateful, I mean the stateful means the database.
Databases.
Stateless means applications. Okay,
Okay. Yeah. Thank you, sir.
thank you. Please, next question.
Sir, if the service goes down, is there a chance that instead of the pod, the service also can go down?
Yes. So what is your question?
I mean, in that case, how it will recover? I mean, service is also doing the load balancing, right? So if the service goes down, what will be the repercussions?
Yeah, that's a very great question. So that's where I mentioned briefly about the self-healing capabilities of the Kubernetes. That how the recovery works. So Kubernetes service is an abstraction over the top of the pods. A service object, usually you would not find it going down. It is because it is a logical abstraction. It is a mapping to the pods via the labels and selectors. So usually in the production system, you would find the pods behind the service crashes. They might face out of memory, they might face node failure, etc. So Kubernetes has the controller manager, as I mentioned in the last lecture, which ensures the service object exists. And if the pods behind that fails, the replica set or the deployments automatically recreate them. So if you have a deployment with the 3 replicas serving the traffic, and if one pod crashes, then replica set or the deployment set, it would be responsibility of that to recreate it. Okay. And if the node goes down, then all the pods on that node become unreachable, and then kubelet stops heart beating. Where in this situation the Kubernetes would mark the node as not ready, and pods would be scheduled to be launched on the other healthy nodes.
Hello, sir.
Yes.
So what is the volume in Kubernetes and what happens to the container data if no volume is attached?
So good question. So as I mentioned, when I mentioned about the volume on your screen, as you can see, it is a storage abstraction that attaches the persistent storage to the pod. Unlike the containers, volumes allow the data to survive in a case of a crash or restart. So the containers file system, that is a volume, is persistent storage, whereas the containers file system is ephemeral in the nature. So if you need to store the data, if you need to save the data in the case of an the port goes down, etc. situation, you would need a volume, persistent volume. Is it clear?
Yes, sir. Yes, sir.
Okay. Any other question? So let me see the chat window also. Okay, Ajit Yadav has a question. And I think, do we one service for each pod? This is a very common confusion when people learn the Kubernetes for the first time. The short answer to your question, Ajit, is no. You do not need one service per pod. What is a service in the Kubernetes? A service provides access to one or more pods. Pods are ephemeral, so IPs change. Services gives a fixed name and cluster IP to reach pods. A service maps to multiple pods that match its label selector. If you have 5 replicas of an Nginx pod, then one service can expose all 5 pods behind a single endpoint. Okay, so if you have 5 replicas of an Nginx pod, I repeat, one service can expose all 5 pods behind a single endpoint. This is a most common scenario you would find. You would host a web application with 5 replicas. So this is horizontal scalability that I'm talking about. One service would be there which would load balance the traffic across the all 5 pods. Is it clear? Yes. Okay, thank you. Let's proceed further. So let's learn about the deployment. While we create an application, I can create an application using the port. I can specify the port and so on and so type. Now, if I want to create the replica of the ports, then I would use the replica set so as to create the replica of the port. But these things does not really help in the production environment because they do not scale well. So in practice, what is done? Mostly the deployment in the applications will happen through the deployment as a component, but not as a port or the replica set. So we create a deployment scenario for the deployment blueprint, which would have more details of it. What is a container? What is a port that is going to use? How much of the replica sets it needs to have? Okay. All of these details shall be there in the deployment blueprint. And this deployment blueprint would be used to deploy the applications. The deployment would not do the replication of the databases. Okay, because when I talk about the database is a stateful information in the form of the data, which is stored in the remote data. If I create multiple replicas of it, so there is this DB, then there is another DB, and both of them would try to update the storage. That is the database. And that would create inconsistencies. Therefore, in order to avoid this particular type of inconsistency with a multiple master database, what it is suggests is that we should only run a particular pod, which is DB. That is, the DB should only be running in one pod, which needs to talk to the database. Therefore, it is suggested that you should not create the replications for the database via the deployment. Now, but you may ask me a question, sir, what if the database goes down? To avoid that, there is only one DB which is maintained, and there is another component which is called as stateful set. When you use stateful set, it will create a replica of the database and make sure that the data is not lost. Okay.
So can you come again on the stateful set? How will this help me? What will it do in the background?
Sure. So stateful sets in the Kubernetes is a special kind of workload controller that you can imagine when you need to have the stable identity and the storage of the data. So the stateful set is just similar to a deployment, but it is meant for the stateful applications like the databases, or for example, like the Kafka, message brokers, etc. The stateful set would provide each pod with a persistent storage.
Okay.
So if you want to have an identical clone of your database with the replication role, then you would be using the stateful set. So if you really want to host the databases like MySQL, Cassandra, Postgres, MongoDB, etc., or the distributed systems like Zookeeper, Kafka, or the Redis on the Kubernetes, then you would heavily use stateful set.
So this is not on top of any container. This is altogether separate service, right? Which is, it keeps on running irrespective of the DB or any container going down.
It is like a deployment.
Okay, so underneath it has a container running, or how is it?
Of course, it would have the container side because deployment is a superset of the service. Service is a superset of the pods. So of
So
course, the stateful set it would be the pods also, no?
then how will it provide me redundancy, because my pods keep on restarting, right, in the backend?
Did you understand the concept of the stateful set?
I understood that it provides each pod with a persistent storage, but if it itself is running on top of a pod, right, as an abstraction. So we initially discussed that we don't keep DBs in pod, right, but persistent set itself is a part of an abstraction of a pod, right? So maybe that's why I'm getting confused.
Yeah. So let's understand carefully. So a stateful set basically is just like a deployment. So you understand deployment?
Yes, yeah.
Okay. So the first of all, deployment. Let me explain deployment for 1 minute. So see, what I talked about deployment is a controller. The deployment is a controller that is going to manage the stateless applications. Okay. For example, if you have your web application, you have your API CRUDs, etc. So the deployment would make sure that you have the desired number of the pods running, and pods are controlled also. So if you want, say suppose 10 replicas of the pod running at all times within the container image with this particular container image, then the deployment would be used there. Okay, so simple. If you want that, hey, I want 5 replicas of my Nginx based web container, then the deployment would make sure that you have that 5 replicas running. And using the kubectl, kubectl, you can also do the scaling up, scaling down. When I say scaling up, this is scaling out. Basically, the horizontal scaling. Basically, you can increase from the 5 ports to 10 ports also during the traffic spiking, etc. Cool. That is the deployment concept. Now, coming to the stateful set, the deployments is used to manage the redundancy in the stateless applications like the API CRUD, web container, etc. Whereas the stateful set is used for the stateful applications like the databases, Zookeeper, Kafka. So in the case of the deployment, there would be 5 pods as I gave you the example. All the pods would be identical in the nature, whereas in the case of the stateful set, they would have the identity. And this identity would make these pods as a different. In the case of this deployment, we do not need to have any persistent storage because it is stateful, because it is stateless. There is no need for the persistent storage. They are ephemeral in the nature. But your understanding is right, because in the case of the database, we are going to store on the pod, we need to have the persistent volume. Therefore, in the stateful set, the persistent volumes becomes absolutely mandatory to be used.
I got your point, sir.
Okay.
Thank you.
So yeah, so that's why the stateful set is used. But I'm not going into much details right now. Let's proceed further. So as it's stated here, for stateless applications, we can make use of the deployments. For stateful applications like the databases, Kubernetes provides us an option with a stateful set. So now with this, we are entering into a state where we would be able to explain you the configuration files much better. This is a configuration file that we write. So you can say here the value of the kind is the deployment. There's a the most important thing. This kind can be the pod, this kind can be the replica set, this kind can be the service, this kind can be deployment, etc. etc. There can be various types of the deployments, as I mentioned, kinds of the deployments, kinds of the things that you can create. Here, the kind that I'm using is the deployment kind. So this is the configuration file of the Kubernetes. So deployment is a type of the template in order to create the pods. Here I have used the deployment. Then the metadata information says that it is the name is my app. And there is also a label which is provided to this deployment, which is my app. Because this label would be used later on for the specifications. And if you see here, it says that spec. Yeah, the spec. Meaning to say, whatever the deployment you are doing, its replica value should be always 2. And it would match the label to the my app. That's where I was saying, bacho, my app is a identical identity. It means that every pod running would have the same label, which is my app. That is very, very important to understand. And therefore, when I say, I just mentioned a few minutes ago that in the case of a deployment, pods are identical in nature. It means that they have the same my label application, my app. If you see here under the specification, there is nothing but the specifications of this deployment, right? So this is the spec of the container that would be hosted inside that pod. It says, now I start again. It says the replica is 2, meaning to say whatever the deployment you're doing, its replica value should be 2. Next, it would match the my label to my app. Now, why is this important? Say, for example, you're running the 2 replicas, one replica dies, then Kubernetes would have to restart that particular application in a new pod, right? For that, this name does matter. Basically, this name should match. And then that spec also has a template, which is a metadata information saying that the application is my app, and the templates also have a specification, which is the details of a container. So for container, what is the name that you want it to give? Here we have suggested the name as my app. Note that this is a user-defined name. What is the image that we wanted to use? Is it a custom image, or is it Ubuntu, or that we want to use, or is there other something that we in the repository that we may want to use? Those kind of details needs to be specified over here. And next are the environment variables. If you want to pass on some environment variables to this container, that can be passed over here as the name or key value pair under the environment variables. As you can see, we have passed the 2 environment variables, the name and the value. Now you also need to specify a port at which this container needs to run. Here we have specific type of the port as 8080. So we give this particular input through either a UI using the dashboard or using the configuration file. That is, you can actually have a configuration file using a script or provide it using the CLI as well. So it accepts both the inputs in the form of YAML or the JSON. And if you're using the YAML, then I'm sure you know the pain points. You need to make sure that the spaces are well maintained here in the script, but it helps you to avoid the braces. So when you provide all of this, you provide it through a command known as kubectl. Kubectl is the one which takes this particular input and triggers the rest of the other deployments. Okay. This is very important, my dear students. Please understand it very, very well. This is the entry point to the Kubernetes cluster if you want to launch a new deployment with the 2 replicas. So we talked about the replicas. Basically, these replicas, whatever we have mentioned, the whole configuration file is a declarative file. And you notice here that we had specified the replicas as 2. So 2 is the desirable state. But if one of the replica goes down, the actual state in that case would be 1. This information would always go to the etcd, and from there it shall be picked up by the controller manager. Controller manager would keep on checking from the database, which is etcd. Hey, what is the desired state, which is being mentioned in the configuration file versus my actual state, which is the current state of the application. If there is a mismatch, then automatically controller manager is going to restart that container, or it is going to spin up a new container, new pod basically. That's how the auto healing functionality of the Kubernetes is being maintained. So the configuration file here, I'm explaining you again about the deployment, what we just talked about in the beginning. I'm just explaining you once again. So you can see here, there are, you can see here, the configuration file have got 3 parts. The first one is the metadata information, which you see over here on the left-hand side of your screens. This is the deployment metadata information, where we also have the labels present. On the right-hand side of the screens, this is service metadata information that you have. Only the names is present over here. Okay. And each one of this would have their own specification. On the left-hand side of your screens, for the basically you can see for the deployment kind, it has its own specifications. The deployment kind would have to have more details, which is there you can see on the right hand side of your screens, which is the line that you can see here, right? For service kind, it has its again own specifications that may not be too elaborate as it being shown here. But the thing is, the service and deployment goes parallelly. Deployment is used to manage the redundancy of the ports, whereas the service is used to be exposed as an abstraction over the top of the ports. And the third part is the status part. Of course, the status is not being mentioned over here, but this is something which is being maintained by the Kubernetes. It is being continuously monitored by the Kubernetes, where it keeps on checking between the desired versus the actual state, as I mentioned. So if it finds that the desired is lesser than the actual, immediately the controller manager would make sure that another copy of the same would be started again. In order to do all of this application, in order for the controller manager to make sure that to restart a particular container, where it is getting all the information from, it is all put into the etcd. From etcd, it is updated into the status information. The status information is being collected by the controller manager. The controller manager would make sure that the desired state versus the actual state are both matching. So generally in the production cluster, we have more than one master nodes. And as you can see over here, there are 2 master nodes on your screens right now, and there are multiple virtual machines as the worker nodes. This is the control plane, and this is the worker plane. This is the slave nodes on which the pods would be spinned up. Our deployments that we just talked about are spinned over the top of the pods, whereas the controller manager, the control plane would only have the features like etcd, controller manager, scheduler, API server, etc. I talked about the control plane in the last lecture. In this plane, I talked about the data plane, which is nothing but the composition of the master of the various worker slave nodes. I hope the picture is getting clear. So now if I want to try out my local setup, you can either use the Minikube or Micro K8s, or K3s is also there. These are all like single node setup. There is a master process as well as a worker component shall be running on the single node. And in the lab setup, we have this, the master and servers worker node separately. Now let's look into the config details quickly for the config map. So far we talked about the config map, but we talked about the secrets, we talked about deployment, services, along with each one of their corresponding examples. So here we have the config map with the name mongo-config map.yaml. The kind here is config map. The metadata, what is the name of it? The data component, the URL is the mongo-service. When I mention mongo-service over here, I would have to make sure that when I define the service name should also be same. Another component here is the Mongo secret. The kind is, you can see the secret. The type is the default arbitrary key value pair which can be given. The type is opaque here. There can be other types as well which can be explored as well. And as you can see here, MongoDB user and password have also been given here. These are the base 64 encoded values, strings. This could be easily decoded. So therefore, for the production environment, we need to make use of the third-party encryptions as well. Next, we proceed to Mongo deployment YAML example. This is both deployment as well as service, which is being separated by the 3 dashes. You can have a separate Mongo service and a separate Mongo deployment. Usually the practice is to combine both of them so that the deployment always have a service along with it. Okay, the name is being defined over here and the specification is also being defined over here. The replica here being defined is 1. Earlier we mentioned that the replication for the DB should always be 1. If at all you want to have a database in a redundant manner, then we should go for a stateful set. Then we have the template. It gives the configuration of the pod. It gives the blueprint of the pod. It also has the labels, which are required fields for further usage as well. Then we come to the specification of the containers. We have defined the name of the container which we are creating. Which image should I be using? Mongo 5.0 is the image which needs to be used. Which port at which it should run? 27017 is a port at which the container powering to the MongoDB should be running. Next, we go to the environment variables, from where we specify that how can we pick up the username and the password from the secrets file. Environment variable name is mandatory to be given here. That is Mongo _initdb _root _username. Similarly, the password environment variable is Mongo initdb root password. As you can see over here. And here the value has been picked up from the secret key reference, which is this. The username has been picked up from the Mongo user and the password is picked up from Mongo password, which we earlier defined in the YAML config file. Finally, we have the service part as such. Once the port is created along with this, the service is also created, which would get the IP address from the virtual network. Here the service name for the Mongo should be same as that we mentioned in the config YAML. So when the request comes to the particular Mongo, it shall be forwarded to that particular service, and same shall get service from that particular pod. And target pod is the deployment pod of the container. This is where the container would serve the request coming to it for the database part. And this port is for the service itself. Of course, we can give any other value as well, but to keep the thing simple, we have kept them as same. Next, we have the web application. Here we also have the replicas as 1. The kind is the deployment. And here we have also specified the name of the container along with the image specified from one of the well-known tutors. It runs in the container port as 3000. One very important thing to note here is that in order to access the database, we need to give the environment variables in the form of username and a password. And they need to get the access likewise. Another thing that needs to be configured is the database URL, which is Mongo URL, which we got from the config. Okay. Another thing which is very important is that when you define the service for the web app, you also need to specify the port with which this application shall be accessed. Here you see the specification where type has been defined as node port. By default, if you do not mention this, it would act as the internal service. If you want to make some particular service as internal service instead of this node port, you can specify as cluster IP. Then it would just work for the internal access only and not for the external world. Very important point, guys. Please do remember, please do take note of this. I repeat, if you mention the cluster IP, it would work for internal access only. If you want to make your service as external, you have to specify the type as node port. Node port external, cluster IP internal. Since it is a node port, using any of the node's IP address, I shall be able to access this application using the port number mentioned over here. So if the type is node port, then I shall also mention additional port through which I would be able to access the application. Okay, so these are the three important things that you need to know in the web application. Tell me, is there any doubt? Is there any issue that you guys have in understanding it?
So we'll have to remember the syntax and the content of the YAML file as well, if needed.
Yeah, I think it is important, but these days you can definitely take use of the AIs to
Okay.
learn it and understand it. But yeah, you have to understand it.
Okay.
Any other doubt?
Yeah. Sir, the config map that we are referring, so that is a different file, right? Config map key reference, I can see. And overall, this file is a deployment specification for specific to the web app only. And the secret for with respect to secret, we have different secret file, config file.
With respect to the secret?
Yeah.
Yes. That would be different.
Okay, and we can refer here.
Yeah, of course, we can refer it here if needed.
Okay, okay.
Yeah.
Sir,
Mhm.
could you please explain difference between port and target port? Why do we have two separate entities there?
Which one?
As part of service, web app service, we have port as well as target port. Even in case of DB, we had port and target port. Why do we have two separate entities, port and target port?
Your port and target port is node port you're talking?
Yes.
Port and target. Node port you're asking, or the port and the target port you're asking?
For node port type of web app service, we are specifying port as well as target port, both
Right.
of those two.
Yes.
What is
Yes.
difference between those two is the question.
I,
Here we have
Go ahead, go on.
here we have same values, but what is significance of having both of them?
Very good question. Thanks for noticing it. See, here I have defined this particular piece. As you can see, just below the three dots, you can see whatever is the below is I'm trying to define a service in the Kubernetes. And the purpose of the port here is this is the port which is exposed by the service itself inside the cluster. Any pod
Okay.
in the cluster talking to the web app service will be using this particular port, meaning the service is listening on this port 3000 number port. Think of it like, for example, this is the front door of your service. This is where the entry of the service happens. And the
Okay.
target port is basically the one which is here. It is the port inside the pod where the actual application is running. The service forwards the traffic from the port to the target port. Meaning that here it is same, for example, but if it is like this 3004, it means कि जो हमारी application है, the container itself is running on the port number 3004. For example, your container can be
Okay.
like web application. So it is like the room in which you want to basically enter after you have entered into the service. And what is
Okay.
a node port? This is like a node port service. Kubernetes also opens a port on every node's IP in the cluster.
Mm-hmm.
Okay, so that is the node port service. So
Okay. So
Kubernetes will route the traffic, the service traffic, port number 3000, then node IP, port, and then the target port is 3004.
okay. So that does mean external world will be talking to service on port number 3000, and whatever request is received on port number 3000 will be routed to target port where the actual application is going to receive that request and process it further.
No,
No? Okay.
no, let me explain it. So what I mean is, you can see, right, I have duplicated this. Are you able to see this, what I'm writing?
Yes. 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 We are.
So see, understand the concept. You have a डब्बा सर्वर है, ठीक है? तो
Mm-hmm.
जो सर्वर है जिसके ऊपर सब कुछ चल रहा है, the
Mm-hmm.
pool, basically the node pool node. Now imagine भूल जाओ कि अभी के लिए you have a DNS. So if you want to
Mm-hmm.
access, मान लीजिए you have a server, उसका IP है 10.0.0.34. तो जब आप एप्लीकेशन को एक्सेस कीजिएगा, whenever your application access, you would do it like this 10 dot, so you would like 10.0.0.34, and say suppose here in this case your node port is this, so you would like this 30100. So this is the node port.
Okay.
Now internally it will go to the service, and this service is hosted on the 3000 number port. This is your
Mm-hmm.
port, and
Okay.
it will go to the port which is 3004. This is your target port.
Okay.
This is like this.
I get you now. That node port is not visible to us, sir. Port and target port are, but the node port is fairly grayed out. It is not clearly visible to us.
If you have the, yes, if you have, if you are using the DNS, then it would not be usable, but it is an external node port. It makes service accessible outside the clusters.
Yeah, I get you. I get you. Now, what I'm trying to say is, as part of your PPT, that node port, that section is grayed out for us. Maybe if you can minimize it, or that's not visible. We are just seeing port, and yeah, now it is visible. So that's the reason I wasn't able to understand that clearly. Okay. So node port is the external fronting thing. Once we get request, it will go to server, service, and then pod, actual pod. Okay, I get you, sir.
Thank you.
Yeah, in this example, it is web application. So ideally, replicas should have been more than one, right? Because it's
Yes.
kind of stateless.
Yeah,
Okay.
of course, of course.
Okay. Yeah. Thanks.
Thank you. Any other doubt before I move to the demo?
Sir, I have a quick question here. We can see we define the configuration for the
What's your name?
services, for the environment,
Your
secrets,
name?
and also for the container. Anything specific to pod, I am not seeing. Is it implicitly drawn
Who is
from here?
speaking? Can you please call out your name? Who is speaking? I don't get it.
Gautam.
Yeah, go ahead, please.
Yeah, so from this configuration, I can see service we are specifying environmental variables and container related. Anything on the pod we need not to specify here,
What do you
or
mean?
it will be, I mean, how many pods within a service it will be?
Sorry, I didn't understand your question. What did you want to what is that you want to ask?
I mean, pod configuration, there is no way to specify number of pods within a service.
Of course, we specify, right? Of course, we specify. I did talk about that, right? Where is your so you see the replicas is one here, right? So here the replica is one.
Okay.
That is what we mean when I say uh, the replica is one, and that's where like you're specifying the port configuration inside this. ना this spec is the port specification ना कि जो port के अंदर आपको container launch करना है, that container has to have this particular container image.
Okay.
Is that your question? If you made this replica,
Yes.
basically it means the number of the pods. The deployment will spin 3 pods.
Sir, here I have one question. If you make the replica 3, is there any change we need to make in service for that?
No, service is like an abstraction on the top of the pods, right? It doesn't need to have any.
How it's going to do the kind of load balancing in that case?
See, when I explained this earlier. So how service basically performs load balancing is it basically knows that which are the backside pods which are basically there. The role of a service here is to basically provide a stable IP address and the DNS name to the access port using the config map. So if my deployment has the multiple ports, say suppose I have specified 3 replicas of my web application, the service would automatically balance across these 3 particular ports. Now, when you are creating a service, you are creating either a node port here or a cluster IP. Now, Kubernetes automatically would create the endpoint object. This endpoint would contain the IP address of all the matching ports, which is selected via the selector. The selector here is web app. The selector you see here, it is also the web app. That's how the selector, all the ports with the name web app, where app is equal to web app label would be added to the service endpoint list behind it automatically. I repeat.
Got it. It means like if it doesn't matter how many replica is running, same service configuration is going to work on that.
Yes, exactly. So the endpoint basically selected by the selector should match behind the selector of the deployment. So by default, the kube proxy would use the round robin algorithm to do the load balancing across the pods. So if you have 3 pods running like here with the label web app, then the request gets forwarded to the one of the 3 different pods in rotation.
Okay. Thank you.
Sir, one question here.
Hmm.
If I want to have a web service, which is kind of a supporting service, I don't want it to be exposed to the outside world, then the type would be cluster IP in that case, right? So that it remains visible only to that cluster. In that scenario, node port wouldn't be required, right? To be configured, as in we don't want that to be configured otherwise, right?
Yeah, that's what I just mentioned few minutes ago. So if you want a service only accessible inside the cluster internal service, then the type should be cluster IP like
Cluster
this.
IP. Correct. Yes, I get that. Yep.
Yeah. This is also by default. If you do not specify the type here, then by default type is also
Cluster IP.
cluster IP.
Okay.
It is internally only access. For example, if you really have to launch a backend database or a microservice that talks only inside the cluster, then you would use the cluster IP.
Right. And the other services within the cluster are going to talk to that service via target port. Sorry, port.
Service port. Service port.
Service
Port.
port. Yeah.
Which is this
Okay.
port.
Okay. I get you. Thank you.
Thank you. So if there are any other doubts, I can take doubts. Otherwise, I'll go to the demo.
Yeah, I have one doubt, sir.
Hmm.
So we have different configuration YAML file. Like for web app, we have webapp.yaml, or for Mongo, we have mongo.yaml. So the web app will launch the pods based on the replica and based on the kinds we have selected. And the Mongo will also create a pod that we have specified as we have specified. So how this application will connect to the Mongo for content pod? So is there any configuration we have put it inside the YAML file?
So that's a good question. As I explained, so there is something called as the secrets and the config map, where you define basically, like for example, like this, that this is my access mechanism. So the application would have to read that. So the database which is running inside the cluster would have to expose its service as an internal service, and application would connect using the DNS name in the port. So my application would connect using the string like you would do in the application configuration file, using like the username and the password, which is a type of the secret. So maybe if I can show you, yeah, like this, you would create a secret, and then application deployment would have the environment variables, where it would have the name DB host and the DB user and the DB passwords. So now, like if I go into the application configuration like this, you see, yeah, here, for example, this is my application configuration. In the, you see here, this, pay attention on this. This is the top portion. What I'm meaning here, I have defined the DB username, DB password, and the DB URL, DB host. Yeah. Therefore, that is how the DB service would be connected.
Okay,
Is
so
that
it is connected using the IP like a host, and then credential will require then that we have mentioned in the secrets.
yes?
Yeah, okay. Yeah.
Is it clear?
Yeah, yes, sir.
Should we go to the demo now?
Yes, please.
Okay, cool. Can you see? Can you see the terminal?
Yes, sir.
Oh. So first of all, students, I'm basically have installed, I'm on my MacBook. I have installed the Kubernetes orchestration system. So I have the Kubernetes running through the Docker desktop. It gives me a single node cluster. So my laptop would act as a miniature data center that you can consider. So I'm currently in this. Last time we saw the demo of the Docker. So the first thing, sorry. The first thing that I want to show you is about the Kubernetes version. You see, I have the version 1.32.2. This is the client version that I'm basically trying to use. The command that I used is this, the kubectl get nodes. Please understand, I have shown you one simple command by executing the get pods. Basically, it shows that my Kubernetes is running on the Docker desktop, and I can see there is one node. Docker desktop is acting as both control plane and my worker plane. In this setup, there is a node, my Kubernetes worker, right? And it runs the pods. Since it is a Docker desktop, Kubernetes runs inside a Linux virtual machine, which is managed by the Docker desktop on your Mac. Right now, you only have one node, which means both API server, scheduler, controller plane, etc., and your pods will run on the same machine. Okay. I hope this is clear. Now, I want to create my first deployment. So kubectl is the command that I would be using. I would be using a deployment. So I would create a deployment and I would name it like Nginx deployment. And the image that I would be using is Nginx, and I would be using the replicas as 3. So you see, I have just created a deployment of the Nginx, a web server. Notice here that I am using Kubernetes for 3 replicas. It means I want 3 identical web servers running. Kubernetes would schedule them as a separate pods. If one pod crashes, then Kubernetes will automatically recreate it. That is the power of self-healing capability of the Kubernetes. Okay. Now I can use kubectl get deployments. You see, it shows me there is one deployment and there are 3 ready state pods that we have. Similarly, I can see there are 3 pods right now that we can see. I have taken the image as Nginx image is one of the image standard available images. Now, right now these pods are running that you can see, but none of these pods have any external door. To make them accessible, we have to create a, tell me, everyone, please in the chat rooms.
Service.
Chat rooms. Service. Does everybody understand? I repeat, so far we have not exposed these particular pods to the external world. There is no external world out there. And that's where I need to really make them accessible outside through the help of a service. A service is like a receptionist. It gives you one fixed address and it would help you to balance the request across the pods behind it. Now, I want to expose this as a service that is clear to everyone. So what is the type of the service that I would like to have? Come on, quickly. अरे external तो ठीक है. External में क्या? What is the type of the service? Rahul Bansal. Yes. Node port. So let's do node port. So now what I will do, I will write kubectl expose deployment, and this is nginx hyphen deployment. Right? Why? Because the name of the deployment is nginx hyphen deployment. I want type is equal to node port. Please note, I'm not using the configuration YAMLs right now. I'm just using the kubectl. Okay. See, I have exposed a service. Now let's see kubectl get svc. So you see that node port type of the service has been exposed. This is an external service, my dear students. Okay. So tell me, ये किस किस को clear है, किस किस को non clear है? Now tell me, how would I access this particular service? ये भी जो host किया है हमने इसको external service बना दिया, correct? Is everybody able to understand? How would this be accessible outside the world, to the outside world?
Node port and node IP.
We need to assign a public IP first.
No, wait. I'm asking, if I want to access my application which is hosted, which port it would be accessible upon?
3086.
Exactly,
Okay.
yes. Why? Because the node port is this. This is the node port that we have. Kubernetes exposes the service on every node's IP at port number 30868. So that port is 80, the one that this port number is 80. Don't get confused. This is the service front door inside the cluster. The clients inside the cluster would hit the 80. Okay. So now what I will do, I will just share my screen, that one that I have. So everybody can see my screen, right? So you can see here.
Yes, sir.
Localhost 30868. Right? That is how I accessed it. That is, I'm accessing from my Max browser, so I will use localhost 30868. So 30868 is an auto-assigned port number because I did not specify any number myself, because I didn't use the configuration explicitly in the YAML. Therefore, it auto-assigned me any one port number. Its range is 30,000, I think so, to 32,767. So it would automatically define if you don't define it. Okay. I hope this is clear. Everybody can see my terminal again. Now, say suppose the more customers comes to our website. Now, instead of manually running more servers, I simply ask Kubernetes to scale to the 6 replicas from the 3 right now. You can see, right? I have 3 replicas here. So what I can do, kubectl, I can scale my deployment. What is the name of the deployment? nginx-deployment. And the replicas, I would made it to be 6. That's all. I simply ask Kubernetes to scale to the 6 replicas, and instantly you would see the 3 more pods would appear. You see? The service continues to balance now across these all 6 ports. This is elastic scalability provided by the Kubernetes. Now, where are all these 6 ports running? The 6 ports are running on my computer, on my single laptop. In the production environment, you would usually have more than like 1 node. So you would have like a node pool. That's where it would run. Now the next thing, say suppose you did this particular image is nginx, you use the nginx image. Now I want to update my image, right? Deployment करना है आपको, service deployment की बात कर रहा हूँ. So you would set the new image to new version. In that case, the Kubernetes would itself do the rolling update. So you can set kubectl set image, and then you can just set the deployment slash, because you want to change the nginx deployment. And now you can see nginx should be equal to nginx is do for 1.2.0. You see? Now, I do not want the downtime. I want the update to happen in a rolling fashion. Kubernetes would do a rolling update. It would update. What does it mean? It means it would update 1 pod at a time, while others would keep on serving the traffic. This way, the users do not even notice the upgrade. And if something goes wrong, I can simply do the rollback. So now I have updated my image. Let's ask kubectl to roll out. So now roll out status. I can check deployment slash nginx hyphen deployment. You see, it will say that the 3 out of 6 replicas have been updated. So it will waiting for the deployment rollout to finish. So it will take its own time to finish it. You can also specify the baking time, etc. That is how it can also work. Is it clear to everybody? So far, I have shown you the demos without any YAML file. I just did it manually using the kubectl.
Sir, with increasing the replicas, what we are going to achieve in this context? Yeah.
Horizontal scalability. So scalability is what we have achieved. Tomorrow your website becomes very popular, so you need
Okay.
to really, upscale it.
And so with scaling, what is being done at the back? Is it allocating a like VM? What it will be doing? I mean, for it.
It
For
is
the
triggering ports. It is triggering the new ports.
Yeah.
These new ports are capable of serving more traffic.
Okay.
Sir, how to set up the ingress here?
That's a very good question. Setting about the ingress. So you can use to specify the ingress the commands as well as the YAML based configuration file. So basically the ingress is nothing but it is like the entry point to your cluster. So your service is basically acting here. We are using a node port service, so it is acting as like the IP address through where the traffic would enter. Now, if you want to really want to see the Nginx container in some version, then you would have basically have to expose that using the Nginx ingress controller. So which is already running on the new version, as you can see now that we have just updated. So I can use like one of the open sources available configuration also. So like there's a way for that. And if I'm using the two different applications, then I can just create my routing by exposing it, and I can just expose an ingress resource out of it. Do you want to see a demo of that, or like, is that answer your question?
I got the answer. Is there any short commands? Just I want to access this page from my laptop. Whatever we just set up.
Okay. So first of all, I would have to check. I think I don't remember the commands 100%, but let me just try. So सबसे पहले we'll have to check that where are my ingress controller is there. So it would look for a port which are all there, and you can see that I have this is like the core DNS, my API server. This is my controller. And this my Nginx controller is there. Okay. So now what we're doing is the ingress controller, as you can see, this is not listed by default. So the kube system basically will tell that all the controllers that I have. My ingress controller is not there yet. Usually I would like to have ingress controller code running because I'm using the Docker desktop. So on the Docker desktop, I need to enable the ingress controller add-on manually. So let me just do that. I'm just trying to look into the Docker desktop wala window, which is not shared, I think, with all of you.
Okay.
Just give me one moment. Okay, anyways. So this is, I'm just pasting one of the files with all of you, by the way. So this is the file that we shall be using in order to really create a new namespace basically, so that I can launch the Nginx Ingress Nginx controller. So let's just type in kubectl. What I want to is basically I want to apply. So there are some raw files also available, people, that you can use. You see, what I've done is I have created a new namespace, and now if I want to basically do like this, let me just get the pods with ingress Nginx. Now you see, I'm able to see the Nginx controller also creating.
Okay.
Created a new namespace which is called as ingress-nginx, because I'm using a publicly hosted YAML file. You can get this, and I'm launching a controller. Once the port status is running, you see the port status is running now. I can now create a ingress resource to route the traffic to my service. So now let's go ahead and let's see to button get ingress. So I can see that I don't have any resource found in my default namespace. Okay. So what does it mean? It means that I do not have any ingress resources created yet. It does not mean that my ingress is not working. Okay. So earlier my ingress was not working. I installed a new namespace. Now what I'm going to be doing is I'm going to create an ingress resource. So for that, I will have to write my YAML file, and then I will have to apply that. Okay. So we'll have to write a YAML file for that now, and then I'll have to apply that YAML to get the ingress resource created. Once your ingress resource is created, it would map my local host to the DNS where I wanted it to be redirected. Okay. So once that is done, basically you can try and then you can try to host it.
Okay.
The kind of the deployment file would have to be the ingress in that case. You can write like a full YAML file which would have the kind as ingress, and you can have the host defined over there.
Basically, we need to start this service first, and then we need to write that YAML file and apply that YAML file to create the ingress for any service.
Yes, yes. Okay. Any other doubt that anybody has?
Sir, here we are using the YAML file that is publicly available, but we see the pods here which are goes in crash loop. which are not at ready state. Is that there is a configuration mismatch or something?
No, it was just starting off. Now
Okay,
you see this is
yeah.
running.
So it
It
means
is
that the ingress also be created, I think, right? So we can access this over the internet with using ingress.
no. I have to create an ingress yet. There is no ingress yet. It is only I have created a namespace.
Yeah. So in the YAML, the namespace kind is also there. Yeah. Okay.
I'll have to create that new. Yes, you're right.
Okay.
That is not yet created.
Yeah.
Tell me, is there any doubt?
So via ingress, it is showing one pod. Is it because it wrapped?
Sorry?
I mean, the last command, kubelet get pods and ingress and nginx. So it is showing one, right? One pod.
Mm-hmm.
But we created earlier 6, right?
Oh, that is not the application one. Huh? The application one is still 6.
Okay.
These are the 6 Nginx one.
Okay, so that is altogether new pod created by the ingress.
Yeah. Okay, cool.
So what is the status that image back?
Sorry?
Image pullback of the image pullback of status for the last 3 pods?
Good question. So basically what happens is that the Kubernetes cannot pull the container image from the registry. It may so happen that, sometimes a Docker desktop cannot reach the Docker hub. Or maybe like the image is like the correct, but it is like not trying to, it is pulling manually on the Mac, but maybe the ports might be struck. So we might have to just, in this case, delete the failing ports and then let Kubernetes recreate them. So for example, I might have to do something like this, kubectl delete pod, and then I'll just supply the name, right? And also supply the other one. So it is see the container is still creating and then pull back off. So sometimes it may so happen, but then you would have to check for the entire details of the ports. If it is still the same error image pull, there's something wrong here. Then you might have to check, right, the kubectl. Then you have to do describe pod. and like this. So you see error response from the daemon, failed to resolve reference. Because I updated the image, right? I updated the image version.
Yeah.
So the image is, there is problem with the image that it is getting. You can see that like the details of that. So this is like kind of the debugging that you might have to do in this case. You will see the exact reason for the image pullback off, and the things like the image is not basically able to be pulled. Now here it clearly says that your Kubernetes cannot find Nginx 1.2.0 on Docker Hub. This version does not exist. So what you can do, you can just do like this. Like this. Instead of specifying like the version, you can just specify the latest. And you can just say updated. Okay. And then you can just say the rollout status. It has rolled out successfully. So now you can see the codes have been rolled out. If you see
Yes.
now the describe, you can just do any one port describe. The one thing to note here is that like the IDs are changing. You see the ID earlier ID was XPMKS. Now XPMKS is not there. That's why this is the meaning when I say the ports are MP mirror in nature. Okay. So now you see the latest version has been applied, and that's what it has been pulled down.
God.
Is it clear?
Yeah. Thanks.
Thank you. So guys, that's all about your Kubernetes that I wanted to show. I hope you enjoyed the lecture.
Yeah, there are a couple of generic questions not related to today's session. Can I?
Go ahead.
Okay, as far as mid-semester syllabus is concerned, are we doing good? As far as pace is concerned, as in what all sessions you had in
What do you mean when you say are we good? What do you mean are we good?
pace-wise, as in are we planning to have any extra session
That you leave on
next
me.
time?
That you leave on me. You don't have to worry about the pace. Okay. I don't like this kind of questions. Are we good on the pace? We are not chasing here the pace. We are chasing here the learning. And our intention in Moto is to really understand the concepts.
Absolutely. Not from that standpoint, sir. We had 6 sessions this weekend.
Yeah.
So I just wanted to check if we are planning to any.
We are good. We are good from that pace, and you're absolutely moving on the right direction. You don't have
Okay,
to worry about that. I'm well experienced into this, and I know how to maintain the pace. So please don't ask such kind of questions.
No, not from that perspective, sir.
No, I understand that, but
Yeah.
but I'm telling you, we are good.
Thank you.
Sir, Ravi here. For the for the practical and all, I think most of the classes, I'm not sure about this class, but most of the classes are emphasizing on the AWS. For us, is it also, are we good? We can use any platform, GCP, Azure as well?
Yes, Ravi, absolutely. That's a very good question. And yeah, I encourage you guys can use whatever the cloud you want to use and you want to try out. But yeah, of course, we are opinionated about AWS as BITS Pilani. So we have done a tie-up also with BITS. The BITS have done a tie-up with AWS. So the labs that you guys have got access to, they are also in the AWS. But I'm open. I'm open to learning everything. So maybe in the next lecture, when we meet in the next Sunday, I'm going to show you some more demos about the Docker and the Kubernetes that go on the Azure. I'm planning to show you some demos on the Azure.
Understood. Yeah. And the lab access, what you just mentioned, I'm not sure the portal access, we have got it. If maybe I might have missed it if it is already done.
Please drop me
If-
an email, Ravi, in this case, because I think many of you rather, I'm under this impression that many of people have already got access to the labs. But if you have not got, so you can please email me. You have my email address.
Yeah. Okay.
This is aditya.goyal@wilp.bits-pilani.ac.in, and you can use this particular osha.bits.codearco.net. That is the URL to access the lab. But if in case you don't have the access, then please email me immediately.
All right. Thank you, sir.
Tanya?
Sir, actually, cloud subject drop down itself is not coming. For other subjects, we have got the access.
Thank you. Can you please email me immediately?
Sure, sir.
Yeah, please email me. Thank you. Mohini? Mohnish, sorry.
Sorry. Yeah. How can we install Kubernetes in our local system? Vara Prasad has suggested to use Minikube. So, can we use this or any other
See,
alternative?
there are multiple ways, Mohnish. On which laptop you have, by the way, like you're using Mac or Windows?
Yeah, I'm having Mac.
Yeah. There are many mechanisms with which you can do it. The way that I have done it is very simple, pretty simple one. So I have just using a very simple direct mechanism of the Docker desktop. This is a recommended way. So Docker desktop comes with the Kubernetes built in. So you just have to do is you have to install the Docker desktop, and in the preferences you go there. Let me show it to you rather.
Okay.
So you see, this is my Docker desktop. You just go into the preferences and you just enable the Kubernetes like this. And then you apply and then you just restart. That's why your cluster would be resetted in like that. And then you can just verify the Kubernetes. That's where we started our demo lecture today. kubectl version, right? And then you can just get see the Docker desktop in the ready state. Another option, which I think one of the gentlemen suggested in the lecture, is you can use the Kubernetes way. Minikube would create a local Kubernetes cluster in your container, in your particular laptop. You can install the Minikube by Brew install Minikube, and then you can start the Minikube also. And then, of course, you can get it. That's also one of the good ways to basically start with the Kubernetes on your MacBook.
Yeah, sure, sir. Thank you. Thank you.
Thank you, Manish. Gautam?
Sir, going forward, I hope one round of session you will be showing on the lab platform also, right? So that.
No, I don't plan to show that on the labs because that is intentional. I want you guys to try out on your own self. See, because we mentioned that we are not really, we are not really tied to any one particular cloud platform. So, and I also got requests from many of your colleagues in my WhatsApp that we can have the demo on maybe any other cloud also. So therefore, I'm past planning in the next lecture to show the demo on the Azure. But I request you to do a consensus amongst yourselves and let me know where you would like to see the demo of virtual machine the Docker and then this Kubernetes. So I was planning in the next lecture for Azure because I received the request from many of you, and we encourage that you guys use your own self for the demos, for the labs. But if you have any problems, you can reach out to me. Okay, Gautam?
Okay.
Rahul?
Hey, hi, sir. Sir, I just want to know, like, is there any kind of tips from your side regarding the exam perspective? Like, how will be the questions coming?
You are asking about the textbooks?
No, for our midterm
Exams.
exam. Like,
Midterm
how we can prepare for the exams? Any suggestions from your side?
Oh, midterm exams, you have to really prepare very well, if you have focus on the class and also you're reading good from the books. the reference books you must have got in the course handout, then I think you should be good. Mostly it would be more practical oriented examination. So you would have like practical stuff there. Like practical stuff is like, for example, it would be industry oriented questions that various domains, various industries, how does the things looks like. This is like your books that you can start referring. But mostly it would be like the practical questions.
Okay.
Like,
And one more thing to, yep.
Please go ahead.
We also heard that makeup exam are a bit more difficult in comparison to regular exams. So is that true? And in this subject?
Yes, that is true.
Okay.
I encourage most of you to attempt the regular paper if it is very much not possible, and if you're very much like kind of out of the town, etc. See, it is a dedication that you have to have. So then it's fine, but I encourage all of you to take the regular paper. That is by design like that.
Okay. Thank you.
Cool then. If everything is good, then
Sir, is there any quiz planned before the midterm?
Oh yeah. The quiz has been open now, so please feel free to attempt the quiz. The subject of the syllabus of the quiz is till today, and please attempt the quiz as early as you can. It is 5 marks and 10 questions, and you have to attempt it into the one go, single go. And if you're not able to finish it in the time of 10-15 minutes, then it will auto submit. So please attempt the quiz.
Okay, thank you.
Yeah, but rest assured, like the paper, I have tried to make the paper as very interesting and very industry specific. So, but you have to apply your common sense. ऐसा नहीं होगा कि पेपर बिल्कुल ही सिंपल सा होगा पेपर, ठीक है ना? जो हमने पढ़ा है उसका बिल्कुल प्रैक्टिकल एप्लीकेशन आपको लगाना पड़ेगा दिमाग से. So that's all. Okay, thank you. When is the paper, by the way? You have the paper on which day?
2021.
2021. So we got one more class, right?
Yes.
ठीक है. तो हम next lecture में खूब बढ़िया से demo देखेंगे, and we will learn more about the stuff.
Thank you, sir.
Thanks. Bye.
It's a very good session.
Thank you.
Thank you, sir. Bye.
Thank you, sir.